So how do we mutate? Like how do we, let's say we have an application, we have to have the things change. Does anyone know how we would do that? Registers, close. You basically, what's that? Close. That's close. That's like more advanced than that's too much. No, it's you just make copies of stuff. So instead of mutating state, so for example, if we go back to this doubler example with the programming, what's happening to the variable I as it goes through this array? Is it mutating? Yeah, it's changing, right? Like you're using a memory register, like memory I, or this variable I, and you keep changing it every single time it goes to the loop. Functional programming, there's no more changing variables. They're like everything's constant, and the only way to do it is to like make a brand new I and then put it in there. We'll get to that. Don't worry about it. Don't think about it too much. Okay, no mutating change of state. No for loops or while loops. Those are gone. I know. Is anyone like freaking out yet? Oh my gosh, how could you? How is this possible? It is possible. Okay, no for or while loops. Those are gone. No. No, those are gone too. Yeah. Yeah. This might be you right now. Are you serious? Yes. Yes. You can do this. You can do this. Okay, so so what can I do, right? There's a ton of stuff you cannot do. But the only thing you can do is write functions. Everything is a function. And that's why we call it functional programming. That's why it's called functional programming, right? Okay. Yeah, right? Okay, so let's get into it. How do we write these like functions without loops? How do we write these functions without variables? Like, how does this work? Oh, okay. After this, why? Why? So, okay. So why are we as programmers spending so much effort not using variables? Like, what's the point? Like, this is a lot of work and totally change the way we think about programming. What would possess us to do this, right? Yes. There's benefits for it. Just like we saw with the object-oriented programming example, you can mix object-oriented and imperative programming styles. Functional is the same way. Like, you can mix and match any of these programming styles together. It's like something you can add on to make your programs better. And we're going to go into all the reasons why in just a second. But, oh, I wish I'd like stub these out. Okay, cool. So, functional programming, it's more concise. So, like, you actually can write code that does the same thing in many less lines of code. It can be faster than imperative programming. So something that can be done really well with functional programming is that it can be spread out on different cores. So like if you're multi-threaded, or like if you're about CPUs like multi-cores, that's all about like making it spread out. It's called parallelizing it. And then easy to reason. I put this with a giant asterisk next to it. So since this is like a functional style, we're not describing the details of it, we're just saying what we want. It's actually easier to read if you know how to do functional programming. So in my experience, what I've seen is functional programming or functional programs look like gibberish to people who don't really know functional programming yet. So something I do a lot is like I'm trying to be aware of my audience. If it's like a lot of junior engineers, I'd probably use less functional code. It's gonna be a little more confusing. But if you like, because it's shorter and more concise and it describes exactly what you want, there's less like fluff, right? I don't have to describe all the for loops. It's just like, I want this data and I want it this way. Like, there's no extra stuff in it. Great. And honestly, so why did I get into it? The biggest reason is I didn't even put this on here. This is like, it's just like to stretch my mind, like to learn functional programming, you kind of have to throw out all the rules of what you learned. And like approaching programming from a brand new perspective has made me a better engineer all around. Like, you can like think of new ways to do it, think of new ways to present problems, more concise ways to solve problems. Yeah, and it totally changes the way you think about programming. Okay, cool. So we're gonna like get in some real code. I was like, I'm sure you're itching to see like what this actually looks like. So before we get into that, I just want to talk about that side effects thing. I mentioned it very briefly. So let's go into that real fast. So if you write a function with no side effects, that means that that function doesn't rely on any outside data. All right. So or it doesn't change any other data outside of it. So we talked about how if you run that function, it won't affect anything else that's happening outside that function. So this is an example of a unfunctional JavaScript function called increment. So what happens the first time you run this? Down here. What does this return? One. Yeah, it's one, right? It's not a trick question. Just one. No, it's one, right? So it's right. It's just taking a is incremented 0, and we're increasing that by 1. What about the second time we run that? 2. What about the third? 3, right? Yep. So every single time we run this, we're getting different results. Why? Yes, this has a side effect. It's affecting data outside the scope of the function. So that's that. Data doesn't change data that's outside of the function. So think about this as an engineer, right? As a programmer, I now have to understand two things. I have to understand how increment works. I also have to mentally keep track of the state of the application. I have to keep track of time and the function all at the same time. Like that's like this is a simple example, but like on front ends when we're managing like crazy amounts of state, like that becomes really hard for us to maintain. And we're like, okay, then this happened, and then state should be here, and then that changes this how this function runs over here. Like that gets crazy. As that starts scaling up, that's like doesn't work. So does anyone have any ideas of how we could transform this into a functional function? It would basically mean it doesn't have side effects, so it can't affect data on the outside, and it has to return the same thing every single time. Yeah? Yeah, please. It is, yes. Oh, I see what you're saying. Actually, you may be right, actually. Let's change that. You might be right about that. All right, what about if we did it like this? So we'll do A++. There we go. How's that? Yeah, there's a difference. Yeah, there's a difference between before or after. Yes, the before returns or after the returns. Yeah. Yeah. There is a difference. That's okay if you didn't know that. That's fine. So yeah. Okay. So okay. Now it's affecting A. Now it's affecting A. So how could we get it so it doesn't mutate outside or change outside data? Yes. 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 Oh, beautiful. Yes. Yes. This is a functional function. So now this no longer has any side effects, right? Now we pass in a number, and every single time we run it, we get the same result back no matter what. I don't guess what's an attribute. I don't know what that is. Yeah, I guess like an argument is that we're talking about, or like yes, yeah, argument. Yeah, so like yeah, this is arguments is how we pass around data now. Yep. So in order to like not mutate that state, now we can have just predictable functions that are self-contained. So now, as an engineer, I can write functions, and I don't have to worry about other things changing outside of it. Because like if I didn't make this past function, like if I didn't write this, I may not know that A is at the top of the scope of that file. I may not know. I may miss it, or maybe it's somewhere else, or like maybe I don't know, right? Like that stuff can get lost really easily. Yeah. Yes, you want. That's like a rule. What's a rule? Like you want to keep things as private as possible. So like, a good rule I have is that when I'm building stuff is like if I start introducing global variables like a here, like that's like probably something's wrong. Like I should. There's probably a cleaner way to put that to make that code work the way. Because anytime you start introducing side effects, that's like you're just adding cognitive load for other people and future you to solve those problems, which sucks. And now you don't. Now we don't have to worry about it anymore. Okay, cool. So side effects. Does anyone have a question about side effects? So basically, to recap, you should write functional code is about writing functions with no side effects, which means that it doesn't affect anything outside of it. And a good technique for doing that is just passing all your data through as arguments or including it locally. Cool. And actually, okay, cool. Great. No side effects. Cool. All right. No for while loops. This is the other doozy. This other doozy. So, does anyone have a guess how we can write code without for loops or while loops? Yeah, recursion's one way to do it. Yep. There's another way too. These are like the really weird methods in JavaScript you may have like heard of before, but like you've been too scared to touch. Copy paste. That's like the first thing you learn. Stack Overflow, copy paste. I saw another hand over here. Yeah? Map. Yes. Map. So a lot of program languages have this, including like JavaScript, Node, Python, whatever. There's a lot of program languages that support these kind of methods. But map, has anyone ever seen or used this before? Yeah? Okay, cool. If you haven't, like I've been using JavaScript